you are going to learn some information today that will help you and your students, not only with testing, which is sort of where this started from, but also ways that you can work with student engagement and ways that you can connect with your kids, whether you are in the classroom or learning synchronously or asynchronously remotely. Welcome. My name is Beth Nash. I am the Testing Measurement Specialist for Mathematics for the state of North Carolina. So what that means is if there are any kind of North Carolina state assessment, so whether that's an EOG or a North Carolina check-in or an EOC, those all fall under my purview for mathematics. Today is the third of 3 webinars that we have offered this fall. The first one was on the 4-function calculator, which was geared for elementary teachers. Last week, we did a webinar on the scientific calculator, and that one was geared for grades 6, 7, and 8. And today's is on the graphing calculator, which is geared for grade 8 and also high school courses. Grade 8 is a little bit of an oddball in that it's the only grade level for which kids can have 2 different calculators. So grade 8 students on their North Carolina state assessments, they can have the scientific calculator and the graphing calculator, which is why there's a little bit of an overlap there. A couple of just sort of housekeeping things as we move through today. We have muted everyone due to the size of the call. We have 1,000 seats, and we've still got folks joining us. We're at about 500 right now. We know that not everyone was able to get in, and we apologize for that. We're limited to the 1,000 seats, and we can't extend that anymore. As a way to work around that, we are recording today's webinar, and the webinar will be sent via email to anyone who registered. So registered whether they are here with us today, or if they, something came up. I had several folks email me with last minute things. Even if they don't attend, but they did register, they'll also receive the recording. When you get the recording tomorrow, it will have a link and a password, and that is able to be forwarded to others. So perhaps you have, others maybe in your PLT or PLC who weren't able to attend today. You'll be able to forward that email and share the information with your colleagues that way. We also will work, it takes a couple of days, but we are working to get these webinar recordings transferred into a YouTube file, and we're posting those on our website. A couple just kind of common questions that have come up over the course of the past few weeks. NCDPI is not offering any CEUs for participation in this webinar today. If that is something you're interested in, it may be something that you can speak to your county about, but we are not offering any credits for watching the webinar. Today's featured calculator is the calculator that we embed for grade 8 and then our NC Math 1 and NC Math 3 tests at the end of the year, and also our NC check-ins for some of those lower ones. And a bit.ly link to get you there is there below bit.ly/NC graphing calculator with the capital letters. That will give you a direct link to North Carolina's version of the graphing calculator by Desmos. And the last link is the link to today's slides and agendas and all of the training materials. We are very, very fortunate that we have with us Dave Sable, who is an amazing presenter and a Desmos guru. And he has curated a whole folder of wonderful activities geared for grade 8 and high school math courses. And he'll be working off of those slides and presenting those slides today. And the bit.ly link to get you there is that last one on the screen. I will be sharing both of those links in our chat here in a few moments. Due to the size of the call, we are asking for a little bit of help in how you contact us. So you should see at the bottom of your screen a Q&A feature and also a chat feature. Just because we've got 1,000 folks attending today, if you have a question that's related to the content, If you have a question about North Carolina testing, how this relates to testing, or perhaps you have a question for the presenter, you'd like, you have a question about how to access a certain feature, or you need, a quick rewind of what he just said. If those kinds of content questions, if you could put those in the Q&A, the Q&A allows me to go in and select a question and reply to it. Kind of keeps it a little bit tidier on my end. We will be stopping periodically to address common questions that pop up in the Q&A, and to just kind of reinforce some important facts. Those that maybe the whole group doesn't need to hear, I will make an attempt to respond to those one-on-one in the Q&A as they pop up. The chat feature, we're going to use that. I'm going to share those links, as I said, and when we get later and perhaps Dave needs to share another resource, or he's wanting to do an interactive activity, I'll be dropping those kinds of links in the chat so that we can all see it. But otherwise, we're going to ask that you all limit use of the chat for technical difficulties, and just to help us kind of streamline and help as many people as possible. If you have technical difficulties, like for example, maybe you can see what we're sharing, but you can't hear us. If you will send a private chat to Stephanie Boyd, Stephanie is a colleague of mine, and she is going to try to help folks with connectivity and technical difficulties. We've added about 100 people since I started, so I'm going to rewind just a second because I'm already seeing a bunch of these questions in the Q&A. That today's webinar is recorded. You will be receiving a copy of the recording late today or in the morning. You'll be able to share that recording with others. The recordings for the ones we've done the past 2 weeks, so the 4-function calculator for elementary school and the scientific calculator for middle school, those are available now. And if you would like access to those, if you would just send me an email, and I'll make sure you have my email before we leave today, I'll be happy to direct you to those recordings and those training materials that Dave set up. Again, please type your content-related questions in the Q&A box. Some of those will be addressed verbally as we go through, and others of those I will try to respond one-on-one. If you are having technical difficulties, please send a private chat to Stephanie Boyd, and you should be able to select her from the drop-down box there. And Stephanie is going to work with you to help you maybe with connectivity issues, or if you're having problems with volume. She's going to be your best resource for getting some help with technical support. At this point, I'm going to turn it over to Dave Sable. Dave is a classroom teacher, and he is a Desmos master. We are very fortunate to have him with us, sharing all kinds of good things. At this point, Dave, if you are ready, I am going to turn the reins over to you.
All right. Here we go. Thank you so much for having me. I really appreciate it. Let me share my screen over here and go over to this screen right there. Perfect. My name is Dave Sable. I am a high school math teacher up here in Cleveland, Ohio. I teach at St. Ignatius High School. I've been teaching for, I don't know, about 15 years or so. For what it's worth, this year I'm teaching Algebra 1, I'm teaching pre-calculus, and I'm teaching AP Calculus. But I think I've taught a lot of the typical high school courses in there over the years. But yeah, I'm happy to be here for the third of the 3 sessions here with North Carolina. If we're going to talk specifically about the graphing calculator and some of the activities also today. And we're doing this definitely with a lot in mind, since there's a lot going on in the world. We'll get to that too. Before we do that, just one more reminder that that bit.ly link, bit.ly/NC graphing calculator, everything lowercase, will take you to this file right here, which is a sort of notes file that is going to summarize everything that we're doing today, and then also has some links to take you further into where we're going to go. And I'll be referencing back and forth to that as we go here. But so let's talk about why we're here, why we're not here, what our hopes are. You know, we're not here to develop theoretical knowledge of teaching and technology. That would be a great conversation. Desmos has done a lot of work on that. but we just don't have time for that right now, just because it's a 1-hour session, and because basically, you know, as teachers today in 2020, we are sort of right next to everything kind of being pretty intense and pretty crazy right now. So we're looking for something a little bit more practical right now. And we're not here, unfortunately, maybe to develop expertise in new teaching and technology, because we, again, don't have the time to really get into that. Instead, what our goal is here to, you know, stick your foot into the new school year with practical tools and ideas for distance teaching than you had yesterday. And a lot of the things that we're going to go over are excellent, both for sort of very traditional, typical in-class sorts of experiences, but also, you know, for teaching students remotely, teaching students purely asynchronously, synchronously online. A lot of the stuff we're doing now that we're going to be talking about is applicable for a lot of those ideas, because as we know, you know, you have all these plans, and then the school year sort of develops and the pandemic develops, and suddenly we're being asked to do things that are not exactly what we planned on, but we still want to try to accomplish some of the goals that we set out to. And then finally, we are going to leave you with a lot of resources so that if you see me do something in this session today, you will have the ability to pick up on that thread and develop it on your own. Because like I said, we have a limited amount of time, and a lot of the things that I'm going to present to you are going to be more of a show, not tell way to describe what's going on. So I'm going to demo a lot of features that you can see. You can go back later and watch the video if that helps. But another thing that you can do is pick up on some of the resources I will leave you with, and that way you can kind of continue your journey no matter where you are. I am certain that some of the people on this webinar have had experience with Desmos. Some of you may have had a lot of experience with Desmos. And I'm also certain that some of the people on this webinar have never opened it at all. And all of that is good, because I will leave you resources that can pick you up at any point on that journey. So just briefly from this point forward, here's the agenda. We're going to talk about the graphing calculator itself for a while, including some details on the North Carolina version of that calculator. After that, I will give you a little demo on how you can use some of our activities to teach with Desmos in the classroom. As long as we have time, I will also give you some starting points on how you can customize some of those activities and build your own activities. And then finally, we're going to leave a lot of time for Q&A. If we don't have enough time for 3, it's because we're giving a lot more time to number 4. And I think that that is a good thing, because I want to make sure that we leave with a lot of the questions answered. And we'll stop, before moving on to number 2, we will stop to see if we have any questions on the graphing calculator as well. So let's start by just looking at the graphing calculator. It's sort of the flagship primary resource that Desmos offers. So I'm going to jump over to a new tab myself, and I'm going to start demoing some things for you, and we'll have some fun with it. So here's a new tab. I'm just going to start out with Desmos.com. Here we are. And just looking at the front page here, there's a lot to look at. The main place that we're sort of drawing you in is exactly where we're going to go in a minute. But just notice up here, there's a whole math tools menu. The graphing calculator is certainly on there, but so is our scientific calculator, which I demoed last week, and our 4-function calculator, which I did 2 weeks ago with North Carolina. We also have a matrix calculator that's interesting to some of the, depending on what subject you're teaching. This is a nice little a way that we can add matrices and do all the kind of cool operations that matrices would demand. We also have a geometry tool, and then this is another app that is specifically for test practice, which might be sort of adjacent to what we're going to show you for North Carolina. Let's just hit the graphing calculator and head to it. So if you've never seen it before, this is the basic layout of what you would expect. We have a nice axis right here in the main portion of the screen. And on the left side, we have a place where we're going to be able to add rows and include all kinds of arguments for us. So let me just start off by just adding a simple point. I'm just going to start off with the parentheses. I'm typing directly on my keyboard, although I'll show you also in a little bit how you can use the on-screen keypad to accomplish really all the same stuff. So let me start by just adding a point at maybe like 0, 2, okay? I use my down arrow to add a new row, and now let's add another way, like 2, 3. You see the points are showing up right here on the screen as I go. I can grab and move the screen all around, the axis if I like. I can even zoom in and zoom out. I can also zoom in and zoom out. I'm using the sort of trackpad on my laptop right now to just scroll up and down, and that's zooming in and out for me as well. I can hit home, and we're right back to where we started. So let me add one more point. Let's add, say, 4, 4. And we can see they're kind of lining up just like this. If I want these colors to kind of coordinate a little bit better, I can hold down on this circle, and it can allow me to make sure that they're all nice and red. I like that. So maybe I want to try to graph a line now through. I can type in y equals maybe 2x plus 1. There it is. So here's my line. What I'd really like is for this line to pass through these points. So let me see here. It would have to have a y-intercept of 2. As you can see, once we change an expression, an equation on the left side, we're instantly going to see results, feedback on the right side of the screen. So that looks pretty good. My slope here seems to be a little off. It looks like it needs to be different. Let's see if I go higher with it. That makes it too steep. So maybe I should make it more like 1. Now that doesn't work. What about 0? That doesn't work either. One thing that I could try at this point is I could try A. So A is not any known value yet, but it automatically asks me, do I want to add a slider? Hey, that sounds like a good idea. So here's my slider. So now I can adjust this, and it's automatically going to give me lots of cool options. I can even hit play, and it'll animate for me, which is kind of fun. We can have some really good conversations about why it's moving so fast through 0 and so slow at the ends. But what I'd really like to do is use this to, well, look at that, 0.5. That looks great. I can even adjust that A, and you can even make this 1/2 instead of 0.5. Officially fit my linear through those 3 points. If I wanted to, I could add a folder here. I can name it something, and then I can grab these by grabbing the area next to the circle, and I can drag them into that folder just to make them more organized. And then I can even close that folder. I can even hide all of these elements individually, one at a time, or I can hide the whole folder at once. I'm actually going to do that just so that I can show you that everything I just did, I can also do with a table. So this plus menu over here gives me the options for 5 different types of elements to add. I can add expressions, which are exactly what I was doing. Points and equations, all those are expressions. I can add a note that would really be just text that I can write as exposition. I can also add a table here. So in this table, maybe I could really just kind of mimic exactly what I showed you. That was 2 to 3 to 4. I can also connect those with lines. If I want to connect lines in between, I can change their color. I can even change what the points look like. Okay. So this is one way that I can use a table here. I could use also this table to perform regressions, which maybe I'll demo in a little bit if needed. That's definitely a very nice feature of Desmos, the way that it handles regressions. But before that, let me show you a few other bells and whistles about how I could use this graph to maybe communicate with students, especially from a distance, perhaps. Let me turn this one off right there. And I can show maybe some sort of a parabola. Y equals, let's say, 3 times x minus 4 raised to the second power minus 1. Okay. So there's my parabola right there. And maybe I want to a student this version of the parabola, but I want to add some exposition text. Maybe I would add a note. And I can say, as you can see here, the vertex is at 4, 1. Oh, 4, negative 1. Okay. And maybe I wanted to kind of explain to a student. A lot of times I'll get emails from students that I'm not physically with at the moment, but those students are saying things like, I really just don't understand how this particular graph works or how this problem works. And I know that if I just gave them some bit of graph of math notation with a little bit of explanation, or maybe a graph itself, and if I sent it to them and they could look exactly like this, they would get a better idea of what I'm talking about. But sometimes it's hard because writing math notation in an email can get challenging, and embedding the graphs can be tough. But what I can do is I can send this exact version of the graph to a student. And once I have it looking the way that I like, I either share a graph, and that's going to give me a URL right here that I can copy, and then I can send that to a student. So I'm going to paste this right here. That's the URL I just copied, and it's going to give me exactly what I just showed you. Okay. And I know that on the other end, the student is getting that exact same version of what I see. It's not like a Google Doc. This is the student's own version of this. They can do whatever they want to it. It's not going to impact what I save and send to them. Another way that I can save graphs, by the way, is as long as I'm logged in, which I see that I am right here. Any Google account, by the way, is automatically a universal sign-in for Desmos. But I can take this graph and I can relabel it. Lines, points, and a parabola. I can hit save. And now that graph shows up in my saved graphs. You know, I have a lot of saved graphs from over the years, but this is that one that I just saved first. Once I saved it, in URL here that I can send off. Okay. Let's take a look at a few other features over here. I mentioned that there is a keypad. Everything that I was doing on my keyboard on my laptop can be done also through the on-screen keypad. You see all the basic stuff that you'd imagine to see for a grapher and a lot of the symbols and notation that we would need, right? There's a lot of extras. If I hit functions, you see all my trig functions, including inverse trig functions and hyperbolic trig functions, if you're into it. Over here in the trig menu, in stats, we have a lot of fun tools that you might need to analyze data. If I hit mean, for example, let me actually get rid of that. Let me start a new row. If I hit mean, and I list a few numbers within here, it'll present within that file. And it'll also do the same thing with median. If I take that same line right there, and I make that median, there we go. Now it's presenting the median to me. So those are in the stats menu. As well, we also have some distributions if you are working with probabilities or stats courses that might need these distributions. We can present the same group of data in a box plot, a dot plot, or a histogram. Let me actually try this in a box plot. It's actually going to ask that I put that in a list first. I'm going to make this A equals square braces. I just pasted those numbers in as a list. And there we go. So I called that list A. I now present all those numbers that I randomly generated into this box plot. Well, that negative 19 is showing up in a weird. Right. So we also have over here, I think was there one more menu I wanted to show you? Yeah, miscellaneous, where we have some calculus notation down here with integrals and derivatives. We can also find the greatest common denominator, or greatest common divisor rather, the LCM, other things like that from a list of numbers. And these are all things that I would strongly encourage you to play around with if you think they might be useful to you. Other teachers are looking at these and saying, well, I don't know if that's really something I need in my class, and that's fine. Over here in the wrench menu, I'll show you one more thing about how a lot of this stuff is displayed. First off, we have a projector mode, which I use all the time when I'm demoing things in front of a class of students on a smartboard or any sort of projector board. Makes everything nice and big, not just the graphs on the screen, but also any arguments that I've typed over on the left side there. Reverse contrast might be useful if you are or if you have a visual things easier to see. We also offer Braille capabilities. We have a lot of capabilities for students with different sort of impairments, visual impairments. And we can turn the grid on and off. We can include or not include the axes numbers. We have a lot of control over how the graph is displayed. I mentioned before that I can just grab this and move around, but if I wanted to be more deliberate about where my X max and X min are, I can certainly do that as well. Okay. Then down here also we have a radian and degree mode to choose from. All right. These are some of the basic bells and whistles features that you'll see on the graphing calculator. There is an endless number of things that I could show you right now, but I imagine we have a little bit of a queue of questions building up. Maybe people asking about specific features, or maybe asking me to clarify something that I've already shown. Is it a good moment to see what kind of questions we have bubbling up?
It is. I think you're psychic. The questions are just starting to roll in, and they are some good ones.
Good.
So let's start with kind of just review. Can you show us again how to make a folder and then how to move things to the folder?
You bet, sure. Let me actually get rid of some of these. Well, no, to keep it around, you might ask about something later on. So let me actually make a new folder, a new file here, a new screen, and just get to a new calculator screen. Beautiful. Okay, so let's say that I have, a handful of expressions here, whatever I like. And maybe even one that's just maybe a calculation. Okay. And I want a new folder. So I go to here to plus, and I would hit folder. Right? Now, anything that I drag directly underneath, it's not going to all in there, but if I drag it up just enough, you'll see a little line form on the left side of the row. That means it's now in that folder. Then I can just drag into here. I can name it anything I want. And I can open it and close it for the sake of organization. And then this will turn everything inside of it on or off. So that is how you make folders.
All right, next question. Can you show us how you saved a graph?
Sure. So as long as I am logged in, if you're not logged in, it won't let you save a graph. So just log in. Any Google account will allow you to log in or create a new Desmos account. And then if I just hit this big green save button, it'll automatically save it as Untitled Graph. But if I click on Untitled Graph, I can title it anything I want, And then I can choose to duplicate. I want to save this as an original version. So now that it's saved, I can open this, and it's right here in my saved graphs. Okay. If I add something new to this, I have to save again. It won't auto save. So I'll save this new version, and now that is going to write over what I saved previously.
All right, next question. Can you show us how to get to that keyboard again?
You bet. So right down here in the bottom left-hand corner of your screen, you're going to see this keypad. And the front section here is going to give you all the sort of probably most used characters, operations, and of course the numbers. Functions are over here on the right side. ABC down here, now this might be useful, especially if you're working on a tablet, if you want to access any letters that are sort of outside of the general region that you need, especially if you're making sliders or typing some exposition text for students. You'll see all the other characters you might need in that ABC menu.
All right, can you talk to us a minute about how things are going to look different if kids are using one of the apps versus the web-based version which you're using today?
Yeah, so the apps that we have for iOS and Android and all these things, they should look pretty similar to what you would see in the web-based version of that same device. So obviously the screen size is going to be different, but to be honest, the web experience on any mobile device, tablet or phone, is going to be very similar to what you're going to see on the apps for that particular device as well. So if you go to the Android store or the Apple App Store, you're going to see apps for the Desmos Graphing Calculator, also the Desmos Scientific Calculator, and something called Test Mode, which will allow you to kind of lock things down within that device. And if you open those up again, it's going to be very similar to what you see in the web-based version. However, if you think you might not have internet connectivity, you can't use the web version, so the app would work without internet connectivity. It should be extremely similar to what you would also see in that same screen size. I think, like, for example, on a mobile phone, the graph is above and the arguments are on the bottom of that sort of tall and narrow screen.
And I think one thing that we can't say this enough, whether you're using the app or you're using the web-based version, all of this is available at no charge.
Correct.
So, you know, this presents a wonderful kind of an equalizer, especially if students are learning from home and you're not comfortable sending graphing calculators home. Students can do this from an iPad, from a phone, from a Chromebook, from, you know, a laptop, a desktop. Now, Dave has talked to you guys a little bit about, you know, making accounts, but students don't necessarily need to have an account. Do you think, Dave?
Well, so students do not need an account graphs and stuff that you will make. If you, for example, sent a student a graph, they do not need an account to view that URL. And they do not need an account to create graphs, but they would start an account to save a graph. If the student has an account through their school that is a Google account, that would automatically work as a Desmos account. The way that Desmos works their student accounts, they comply with all of the best practices and requirements for student data privacy. So they're very concerned about making sure that, you know, the student data or the student accounts that are created are dealt with responsibly and ethically. They take that stuff super seriously. And so if you're concerned about that, you should be, but so is Desmos. And everything that we're talking about, everything I'm demoing today is totally free. There's no charge for any of it. It will be free in perpetuity. Desmos does make money off of relationships with publishers, relationships with states, you know, embedding the calculator within their tech, like with North Carolina, for example. But the resources that we're showing for the general public are free. And then there you go.
All right. How about graphing imaginary numbers?
That's a good question. We don't graph imaginary numbers. You can kind of fake it just by plotting the way that imaginary numbers are plotted using the complex plane, using the y-axis as the imaginary axis. So there are ways to fake it, but they don't. It is not included as a part of the graphing experience.
Okay. We've had several questions about transformations, which in North Carolina is an 8th grade standard. Can you show us how you might be able to graph transformations?
Yeah, no, it's a great question. I love this. So one of the things I really love about this calculator, and one of the reasons that I've, you know, really latched onto it so early and so quickly, is because it really deals with math notation in such an authentic way. Let me give you an example of that, and this is a good way to talk about transformations. You know, if I have a function and you know, first off, it's going to graph a function. You might look at this and as a math teacher think this is ridiculous. It shouldn't be graphing anything because it doesn't say y equals sine of x. That's a really good point. But some of the ways that we've set this up is that we want to make sure that this is very forgiving for new students, for new learners. So if a student leaves off a y equals, but they expect to see a graph, and if it doesn't graph and it gives them an error, they might be like, well, forget this and walk away. So we want to make sure that it is very approachable for young learners. So that being said, it'll kind of graph a little bit of, it'll give students a little bit of leeway. However, it also is very authentic with the way that it uses other notations. If I title an expression f of x, or g, you can use any function name you want, but let's just start with f. This is now a function that I can use in any other context. I can take this f, first off, I can function values. I can type anything I want in there and it'll evaluate for whatever value I like. But something else I can do is I can grab that f of x and it'll graph a new version of it. So what I just typed there is another sine function on top of the one that I just showed you. I can take that sine function and I can translate it up. I can take this original one and make it maybe dash so that it sticks out as being different. And I can show that I can also maybe subtract a 3 and shift it to 3 units to the right. I can maybe also multiply the outside of it by 2 and show how I can get a vertical stretch out of that. Or remind myself that if I multiply by something between 0 and 1, something else happens. Or if I make it negative, something else happens. So I love the way that this deals with transformations on this level, because I could actually take this original function now and I can make it like whatever. I mean, I keep going back to x squared, but maybe it is a good example. And how my original function now squared, all those same transformations do something very similar. Of course, it's not a sign function, so it's not going to comply with a lot of the same words that we'll use, but it is doing a lot of the same stuff. It's stretching it or compressing it by 4 and flipping it negative and doing all that kind of fun stuff. I can even maybe take this and maybe make that absolute valued and see what kind of cool stuff happens then. I see this as a really important application of how to teach students how to use transformations and all that kind of fun stuff. So,
can you now within? Let me back up. Staying within the graphing part of Desmos, not switching to matrix calculator. Do you have any availability to do matrices while within the graphing calculator?
No.
Okay.
We can work with lists that are really just one-dimensional lists, but we cannot do matrices directly in the graphing calculator. However, that being said, the matrix calculator is great. And if that's something that you would benefit from in class, I strongly suggest checking it out. It's a pretty intuitive, easy tool to use.
All right, next, can you show us just some really basic, like y equals mx plus b? And then can you connect that to a table?
Yes. So let me actually show you this. So let me start you out with y equals, let's say, negative 1/3 x plus, oh, I don't know, 6. Okay, so there's my graph right there. Something that I can do, if I hit this little sprocket up here, it'll give me the option to potentially duplicate what I started with. Maybe I want to make another copy that's very similar to it so I can duplicate. I can change the color or the texture of the line a little more easily. But I can also hit this button, which will automatically convert this function to a table. So now this function, and I could make a table like this where I could type in there instead. But now I can also take these values and I can change them and the table will respond however I like. And I can add any additional values to here. As I'm doing it, these points are being plotted on the curve as well. So I think that's a really good way to kind of show how a table and that line can be connected. And now I could also talk about regressions. I could do a real quick demo for regressions if that's something that people would like to see.
We actually have about 6 questions on regressions. That is a hot topic and it was on my list.
It's a great one. And it's really a really powerful tool that we offer here, right? I'm actually going to grab a little data first, make it more interesting. I have a little bit.ly link that I can grab data from. Great. So this is a bunch of data that is prices and pieces for different Lego sets. Okay. Let me grab. There's to this. One of it is just showing I can import data into the tool, which is not essential for being able to do regressions. We could always type this stuff in by hand, but I don't want to type all these in by hand. So I have these 2 columns highlighted in this spreadsheet. I'm going to copy. So I just did Command C on my Mac keyboard. I could also do it up here. I could copy from here instead if I wanted to. I'm going to go back here to Desmos, and I'm just in a row. I'm not even going to start a table. But if I just paste, I'm just going to hit Command V, or I can do paste from the menu. It automatically formats all of that data into a table. It also changed my view so that it was a better view for this data. Okay, so it's sort of changed my screen view. So now what I'm going to do is I'm going to find my regression. Now notice that this table named these 2 columns x sub 1 and y sub 1. So those are the variables that I need to use when I'm going to show you this regression. So here's how the regression works. I'm going to go ahead and say y1 equals mx1 plus b. Those show up if I type a 1 after a variable. So that's not a special command that you have to employ. All those subscripts will automatically show up if I type it in x1. Now everything disappeared, but all hope is not lost. What we have to remember here, and this is how I teach it to students so they can remember it, we're not actually saying that y sub 1 has to be equal to those. We're just trying to find the best relationship. And I want to find the value for m and for b that will make that relationship fit the best. So we can't use the equal sign. The symbol that we've picked to show that these are connected is one that we picked from geometry. It's the tilde. And that's in the upper left-hand corner of your keyboard. It is also located here in the ABC menu, right there. And what automatically happened was it automatically graphed my line of best fit, and it's showing me my R-squared value, my R value, and the parameters that make that work. It doesn't matter what you title these parameters. It's just going to work however you want it to work. It'll also work with whatever form you want, okay? So if I had quadratic data, for example, I could do a regression that will work off of standard form. I could do a regression that will work off of vertex form. It doesn't care. You're just typing in the form that you want it to do. You can make up your own form that's never been used by anybody. And it's just simply going to find the values from those constants that'll make everything work the best. And it'll report those out to you. And again, there's more information on our site about how to dig deeper into regressions if that's something that you want to do.
All right, we got a couple more, and then I'm going to let you move on because I see what time it is. What about, if you're familiar with GeoGebra, being able to graph shapes and then perhaps maybe dilate a shape? Do we have capability within the graphing calculator here to do that?
Graph polygons. There's a polygon tool that will allow me to graph, if I list a handful of segments here, just picking some random points. Get rid of these guys for a minute. Oh, and it's so tiny because we're so zoomed out. Let me hit home. There it is. Oh, this was a pretty poor example. Let me see if I can change one of these. There we go. It's a little bit better. So I can graph polygons. Now, this is not that exciting. I could be a little bit more careful about this and use some constants to translate that. What I would strongly suggest, though, is also checking out our geometry tool, which is going to allow for a little bit more natural use of all kinds of transformations, including dilations. So our geometry tool is located from the front page in that math tool section.
All right, two more, and then I'm going to let you go on to show us some of the cool teacher tricks. What about graphing piecewise functions?
We'll do piecewise. So let me show you how piecewise would work. Let me get rid of that one for a minute. Okay, so I'm going to start a new function. And the syntax that we use here, everything is in a big set of curly braces. So I'm going to start my curly braces. And I would type my condition first. So let's say x is less than 1. Then a colon, and the function I want to graph there. Then a comma, and then I'll just repeat. So maybe I want x is greater than 1 for the rest of it. And I want that to be, you know, x cubed. Oops. I forgot my colon, x cubed. Okay. So that is how that works. So that syntax, I can repeat that over and over again for as many conditions as I want. But yeah, condition, colon, expression, and then comma separating the rest. And if you forget that syntax, and sometimes I do, I forget the order, if you Google Desmos Piecewise, you'll always be able to find that.
Great tip, thank you. What about graphing polar?
Yeah, we can do polar. So if I'm here and I automatically use R's and thetas, it's going to know that I want to graph in a polar context. So if I graph, for example, R equals 5 theta, it'll automatically graph within that polar context. Theta, I just spelled out Theta, but it's also located in the ABC menu right here if you want to just use that theta instead. And I can graph any kind of polar context I want. I can also use a polar background if I like that better.
All right, well, we have cleared the queue for the moment.
Cool.
I am going to turn my mic off and let you share with us your next little bag of tricks.
Okay, well, so, and really quick, what I have to show too, which I haven't shown yet, are the North Carolina, right? So let me show you where that is. There's direct links to it on the notes file, but let me also show you how you can get to it from the front page. On the resources here, if we go to assessments, it's going to take me to this big map of the US. If I hit North Carolina, it'll give me all these different options for the different types of calculators. So if I hit this PDF right here, it's going to tell me that for the North Carolina version of the calculator, There's a few things that are disabled. Now, some of them I showed you and some of them I didn't. A lot of them, like some of these hyperbolic and alternate trig functions, are not available. Those might not be too mission critical for you. Some different stats functions and special list functions that we offer probably aren't going to be too relevant anyways. The default angle mode usually is radians, but on the North Carolina calculator, it's degrees. The keypad isn't QWERTY organized, it's just alphabetical organized. And then some of those folders and notes that we could typically use if we're trying to make students disabled for the North Carolina calculator. So if I click on this link, this is exactly what the students would see. And all that stuff that's disabled is disabled on this. And this is exactly what the students would be experiencing on the North Carolina test. There's a direct link to this with that bit.ly link that Beth shared with you at the very beginning. That's the bit.ly link with the capitalized letters instead of the all lowercase.
And just as a quick note on the testing piece of it, the way this works, when the students are testing on the computer, so either using our secure browser or our secure testing app, NCTest, when the kids are at the calculator active portion of the test, which, 8th grade and NC Math 1, there is an inactive portion. For NC Math 3, it's all calculator active. There will be a little icon up in the right corner of the screen that looks like a little calculator. They'll click on it, and then they'll have access to exactly what Dave has got on his screen right now. 8th grade, they will actually have two little calculator icons. The first one will take them to the scientific calculator, which we talked about that last week. And if you need it, hit me up with an email and I'll be happy to send you the information. And 8th grade will also have a second calculator icon that will take you to the one Dave's talking about today.
Great. All right, cool. I am looking to pivot just a tiny bit, Beth, because we don't have a lot of time left, and I want to leave some more time for questions at the end as well. So I don't know if we're going to be able to do a full-on experience with everyone demoing an activity, but I think I'm just going to go over to the site to show where the activities are and how to get people started on them. So I'm just looking for something right here that I can use. Yeah, let me show you this. So another thing that we would encourage you to check out, to think about, that's also totally free, is this tool we have called the Desmos Activities, Desmos Activity Builder. The place where that lives is at teacher.desmos.com. So teacher.desmos.com is the place where you can find all of these cool activities. And as you can see, the first thing you see is just that you have a lot of different places organized generally by topic. You see some individual activities. I'll jump into one of these in a minute. But over here on the left side, you see some opportunities, some options where you can see some different activities that we have separated out here. So if I click on one of these, let me just kind of show you what you would expect to see. So this is an activity main screen. And within here, I see all the way at the bottom, I'm going to draw you to this first, all the different screens that encompass this activity. And I'm going to kind of see the student experience side of this would be. This is kind of demoing what a student experience would be. So, for example, this is an activity that I picked that kind of helps students develop some ideas about exponential functions. And it asked me to grab this point and move it to a spot. And I can give a little explanation as to why I chose that spot and why I think that this is the next logical progression for these points. If I hit next, I do a similar thing again. And if I were a student, I could type some explanation in here and so on and so forth. So this shows me sort of the different screens that I could progress through to complete this as a student. Okay? On the teacher end of things, what you are seeing as students input text, manipulate graphs on a screen, input mathematical expressions, answer multiple choice questions, and all sorts of things is over here. Let me show you this dashboard that I completed, I believe, last year from this activity. What I see here is a layout with all my students' names on the left-hand side. And then throughout here, I see some feedback on how students may have answered positively or negatively, where students are. If students are currently in this activity, you'll see them highlighted with individual cells highlighted to show exactly where they are in that activity. If I click on an individual screen, I can see all of the specific manipulations that students have done with all of their answers as to why they answered the way that they did. And I see other types of screens. For example, this has a table element to it, and students answered with a particular value. So it will kind of group all of the students that answered 7, all the students that answered nothing, and all of their explanations in here as well. Okay. You might see that on the left-hand side here, you might be thinking that this is some sort of a violation because I'm showing you the first and last names of all my students. But if you look a little more closely, Galileo is not one of my students, unfortunately. Neither are some of these other names. They are notable mathematicians. And one of the nice things about this is that this gives me the opportunity to show some of the student work on a screen in front of a class, on a Zoom in front of a class, in a video where I'm breaking things down. And I can talk about an individual student's response. And we can critique it, or we can say what was good about it, what was bad about it. The student can get that feedback because they know what their pseudonym is, but they don't feel outed in front of the whole class, okay? We also have some other tools like pause and pacing. What these tools do is it will halt all the students in their tracks. So if I want all the students to pay attention to me, to talk about something related to what we're doing, I can kind of force them to do that. And I can also pace individual screens that they're in. So if I had students in this activity right now, they only are able to proceed through slides 2 or 3 at any given time. Okay? I can stop that. I can also edit it and force screen time. Okay? Let me think here. If I wanted to start an activity, let me go back here, go back to the activity page. If I found an activity, I said, I like this activity, I want to try out this activity with my class. On your side, you'll see a button here that says create a session. Mine looks a little different because I've connected my Google Classroom class to this tool. That's something that you can do to automatically link all of your classes to this tool so that if I were to click on my AP Calculus AP Period 2 session, it automatically creates a new session for them, and it also sends this to their Google Classroom feed. You don't have to do that, and you also can create classes without using Google Classroom, and it's a better way to potentially organize this. But I can also create a single session code. And what this has done is now it's created a 6-character code. This row right here represents that class's activity. If I hit View Dashboard here, it automatically takes any those characters, and they will automatically be launched into this activity. Okay. That is an extremely brief overview of how these activities work. And we have a little bit of time left, and I can stay a little late, and it might be good to kind of address individual questions on these. However, and this is, like I said, show, not tell. This is extremely show, not tell. I want to point out over here to the notes that not only do we have some notes to pick up your own journey on the graphing calculator, there's a graphing calculator scavenger hunt that I would strongly recommend to anybody that wanted to level up their calculator skills. And no matter how advanced you are or a novice you are, there's a place on that scavenger hunt that you can pick up and work on individual skills. With the activities that I just mentioned, this section right here is going to be where you're going to want to look to pick up on individual things that I may have mentioned that you want to learn a lot more about. If you about teacher access, there's a way that you can send specific written feedback to individual student slides. There's a link for that. So learn.desmos.com, which is our sort of PD area of the website, is where you can find all of the documentation and videos and all kinds of cool stuff about all the different tools that we offer, including the activities.
And to that end, I would encourage anybody who is interested in more of what he was just talking about using the teacher version of Desmos and creating these activities and providing feedback. We had such a great list of questions today that we spent a little bit longer on those than we have in our other webinars. But Dave did a great job. I would be happy to send you the webinar from last week where we were, what do you think, maybe 20 minutes, Dave, talked about.
Well, and the big difference is that there was a lot more, the graphing calculator has a lot more to it, right? So there was more to talk about with the graphing calculator.
So if you are interested in more of that teaching piece and how to use the different teacher tools and how to create interactive activities, I would encourage you to watch. Send me an email. I'd be happy to send you the link to last week where you can get a little bit more detail. He does have all of the links here, but if you want to watch him kind of like, click and go to the different things, that would be a great resource for you. Since we did run out of time today on those.
And you'll find lots of those videos too here on learn.desmos.com. Sorry, Beth, go ahead.
No. We had a couple questions here on the last little bit that you spoke about. Linking to Google Classroom. Can you elaborate a little bit more on that? Are we having to enter individual student names?
No, not at all.
Is that?
Yeah, so as long as the email address that's attached to your Desmos account is the same email address that manages your Google Class account, manage classes tab here, or the section. Mine's already set up, so it's difficult for me to show you exactly how that linkage happens. But we do have documentation on how to make sure that happens. But as long as the name on your Desmos account matches that, it'll automatically bring all those over. It'll also sync them as you go. So if you have students added or taken away, it'll keep those two lists in sync. By the way, if the email address you have on your Desmos account doesn't match it, and you have like stuff that you don't want to lose on the Desmos account, you can change the email address so that it does match, and you can bring everything in. So you do not have to enter individual students' names.
How about if we see activities that we like that are already available on Desmos, can we pick and choose and add those slides to create our own?
Great question. Absolutely, absolutely. Let me see if I can show you that really quick. I'm trying to find an open tab here. There we go. Okay, so yes. Let me show you really quickly if I wanted to make a brand new activity, or even better. Let's look at this. This is something I just made for my algebra students. Okay, this is a very quick activity. They're doing literal equations, and there's another little word problem at the end here. So let's say I want to add a slide to this. So I want to edit my activity, and this would be very similar if I were starting a brand new activity. But this is what the editor looks like. It's similar to what you would see with like Google Slides or PowerPoint. I see all my slides up here. For an individual slide, I'm on slide 1. I see all the different components that go into it. And I have different options that I can put in here for students to see things or enter things. So let's say that I want to add a new slide. Okay, so let me get back to teacher.desmos in a different tab. There we go. And let me just pick a random one. It's kind of neat. If you look here, starter screens, we made a really just built for checking with students and seeing how students are doing, especially if you're distance. This might be something that's really important. So let's say I want to do this. Where are you at today? Drag the point to explain kind of how you're feeling on these two different axes. I really like this screen right here. In the preview, I have this little copy this screen button, and it's literally kind of putting it into your clipboard. Okay, just the clipboard that you have on your computer. So I'm hitting this button to copy. I'm going to go back to that activity I was just working on, and right here, I'm just going to paste. I'm going to hit Command V. I could also do that from this menu right here. And now that screen is automatically dropped into my activity. I can grab it and I can move it to a different spot in the activity if I like. But this is a great way, if you want to start customizing activities, this is a great way to build simple slides and merge them with something more complicated that someone else made that you want to try to bring together. And I can hit Publish. And now this is my own version of this activity. It's brand new. And this is someone else that's URL. I could send to another teacher, and they could also use this exact same activity. They could edit it. These are all the different options you have.
All right. What about when you were showing that all of the names were they had been anonymized? Mm-hmm. Is that something you clicked on, or is that an automatic feature?
It's something that I clicked on. It was something that was already set beforehand. Let me show you in here. So actually, this is the one from last week, I think. Actually, this is the one from the 4-function calculator. Either way, though. So these are other North Carolina teachers. If I hit this anonymize and turn that on and off, you see the names that they typed in kind of go back and forth with those anonymous names. So that's something that actually by default it's off, but just hitting that anonymize button will turn it on.
Okay. What about linking to Canvas? Do we have the ability to do that?
Not in the same way that it does Classroom, not yet, at least. I wouldn't be surprised. This class's functionality is already kind of new. Just a few weeks old, so I wouldn't be surprised if it gets added at some point. You can embed graphs. You know, if you have a graph in the graphing calculator, I can share this and I can get some embed code, and you can use that to embed directly into Canvas without leaving that environment. But you can't, otherwise there's no integration with the activities.
All right. What are your kind of tips and tricks for if you're having students work within Desmos? What would you say some best practices would be for kids to share their graphs with you?
If they're just working within just the graphing calculator?
Yes.
Okay. Well, I mean, to be honest, I mean, just make sure that they have a competency that they know exactly what they need to do to get the copy of that URL and just send me that link. Sending me that link is really the one way that you can share a graph. Now, if you were doing some projects with maybe students do a project within Desmos, a lot of teachers do this where they can create pieces of art with functions. What I would sort of suggest is to make an activity that has a very simple, it's just one screen that's just a big blank graph. And if you do that, then the students are going to be able to do what they need to do on that one graph that's within Activity Builder. But then you are automatically going to see what they're doing on your end because it's going to be inside of your dashboard. I think I actually have an example of that if you'd like to see. I had with my pre-calc guys, my pre-calc students, we were doing something recently with just the 12 functions, you know, the 12 basic functions. And I really just gave them like a playground. And this graph is really just a screen where I put all the 12 functions on. I said, turn them on, turn them off, play with them, do whatever you want to do. And this is what it looked like. So it's just these two screens with some instructions. And if I click on, I can see all the thumbnails of stuff that they created. Some of it's a mess, some of it's beautiful, it's all great. And I can click on one and I can see exactly what this student did. So that's kind of a version of what I think we were just talking about. This is how I would do that kind of thing.
And is that how you would handle doing a quiz as well? If you wanted to use Desmos for a quiz, would you set it up as an activity and then send that over to the classroom?
Yep, I just did one of them today in my AP Calc class. I gave them an activity quiz where they did it in class with me. And I was actually able to give them feedback. You can add written feedback to individual student slides. And so when I grade these things, I add feedback to the slide. Let me show you what that would look like. Let's say I want to give feedback to this student right here. At the top of the screen, when I clicked into that student screen to see what the student did, there's this little button right here. And so I can now type in some sort of a feedback, whatever I like that message to be. I hit send, and now the student gets a little alert that says, oh, there's a message for me on this slide. I can go check that out. So when I quizzes, that's how I kind of give them feedback.
All right, I think we have two left. Can you graph parametric equations?
Yep. Let me show you. Good question. Let me actually make a brand new graph here. The way the parametrics are going to work is they're nested in parentheses, kind of like a point would be. But instead, I am just going to put in two different functions of t. I can also change the sort of domain for the t value. I can send it to pi, I can send it to 2 pi, and then I can get in here and I can make some adjustments. I can do all kinds of fun stuff here. Whoa, that's kind of cool. So yeah, parametrics work within just general parentheses as functions of t.
All right, and what about residuals?
Yeah, we saw some, oh man, did I already get rid of that table? I can make a real tools. So if I get a table going here, and let me just kind of get some real quick data. Okay. So if I do that regression that I showed you, y1 mx1 plus b. So there's my line of best fit. Okay. And residuals, like if I hit plot here, it'll automatically make a new row, a column on the table with the residuals, and it'll also plot them down below.
Excellent. Now, I think at this point, I think we have exhausted our questions.
At least the ones that people have mentioned. I'm sure people have more, but they might want to check later on. Yeah.
And so just a couple quick things as we sort of wrap up here today. I know we've gone a few minutes over. We have recorded today's webinar. The recording of the webinar will go out to anyone who registered, whether or not they logged in today or not. That'll go out either late today or in the morning. When you receive that, you'll be able to share that with whomever you want. You can just forward the email on. The email will also include the link, the bit.ly link to the Google Doc that Dave's been working off of today. We are going to make sure that you have information information to contact us if you need. If you have Desmos related questions, Dave is your best resource for that, and he is sharing his screen now that has that information. If you have questions related to North Carolina testing on how we embed these calculators or what features are allowed to be used for North Carolina testing, so EOGs, North Carolina check-ins, EOCs, I'm your best resource for that. You will be getting another email from me, as I said, with a link to the recording. Please reach out to either of us if you need some help. We are here to support you. I would like to thank you for, after a very long work day, taking some time to learn with us and hear the great resources that Dave had to share. And we hope that you have learned some new things that are going to work out great for your classroom. Your time and your dedication to the students in North Carolina is very much appreciated. And with that, Dave, I'm going to drop your link and I'm going to let you sign us out today.
Okay. Well, yeah, thank you so much for joining. I'm sorry we couldn't get to more, but as I said, I mean, we could even do a week course on this stuff and we would still have more, but I strongly suggest if there's a thing that you were intrigued by, if there's a thread that you want to follow, please follow it. Note the links on the resource I left you. If there's a thing that you want to try to pick, you have no idea to pick it up, email me. Send out an email, hit me up on Twitter. I'm happy to help out. The Desmos community on Twitter is also really, really rich, and there's a lot of people that would be happy to help you out if you tag Desmos and ask for some help, because we are here to help you explore and continue that journey. So yeah, thank you so much, and thanks for having me.
All right. Bye, guys. Have a great night.
Bye-bye.